Limestone karst region. Large stretch of land with unique topography formed by calcium carbonate sedimentary rock. Limestone regions, karst landscapes. Limestone regions, known as karst landscapes, are unique geological formations created by the dissolution of soluble bedrock, primarily limestone, by slightly acidic water. This process, called karstification, leads to distinctive features like sinkholes, caves, and towering rock formations. Covering 10 to 20% of Earth's land, these regions are vital for global water cycles as groundwater reservoirs and support remarkable biodiversity, especially within their intricate cave systems. What makes limestone special? Solubility. Rainwater plus CO2 equals weak acid dissolves limestone. Permeability. Water easily penetrates underground through joints. Organic origin. Sedimentary rock made of calcium carbonate. Key characteristics. Depressions, everywhere, varying sizes and depths across the landscape. Sparse vegetation. Complete absence of thick vegetation cover, no surface drainage. Water disappears underground quickly. Rugged topography. Well-jointed, stony, broken landscape. Dry surface valleys. Water penetrates easily through limestone, leaving valleys completely dry. Underground water re-emerges as springs when it meets hard rock below. Surface features. Limestone regions are characterized by distinctive surface features shaped by the chemical weathering of soluble carbonate rocks. Limestone pavements. Limestone pavements are exposed limestone beds weathered into a grid of blocks, clints, separated by deep fissures. Grikes. Acidic rainwater enlarges these joints, aiding the drainage system. Sinkholes. Sinkholes, dolines, are common depressions formed by the collapse of material into underground caverns, or by gradual dissolution. They act as entry points for surface water into subterranean systems. Grikes and clints. Grikes, progressive widening of cracks by solution, forms limestone pavement patterns. Clints, isolated rectangular blocks, exist between joints or grikes. Depression formation. Swallow holes. Small depressions where rainwater sinks at weakness points. Dolina. Several swallow holes join to form larger depression. Uvala. Multiple dolines combine into even larger depression. Polges. Largest depressions formed partly by faulting. Swallow holes. Small depressions carved by solution, where rainwater penetrates limestone at weak points. Underground features. Limestone regions feature unique subsurface formations shaped by acidic rainwater dissolving soluble carbonate rocks. Key features include cave systems. Unnatural underground voids formed as carbonic acid from rainwater dissolves weaknesses in limestone, creating passages and vast networks. Underground drainage networks form subterranean rivers and streams. They are crucial in karst regions for channeling water below the surface, limiting runoff. Speleothems, like stalactites and stalagmites, are secondary mineral deposits. They form from the precipitation of calcium carbonate, as water saturated with dissolved calcite drips and flows, building intricate structures. Resurgence and springs. The hydrological cycle in karst regions. Surface infiltration. Rainwater absorbs atmospheric carbon dioxide, becoming weakly acidic. This carbonic acid infiltrates the limestone bedrock through natural fractures, joints, and bedding planes, beginning the dissolution process. Underground, flow and dissolution. As the acidic water moves through the limestone, it slowly dissolves the soluble calcium carbonate, enlarging existing cracks into conduits, passages, and eventually complex cave systems. This underground flow can take thousands to millions of years, continuously sculpting the subsurface. Encountering impermeable layers. The descending water continues its journey until it reaches an impermeable geological layer, such as shale or sandstone. This barrier prevents further downward percolation, forcing the water to change direction and flow horizontally along the contact point. Resurgence and spring formation. Forced by the impermeable layer, the groundwater flows laterally within the aquifer, until it finds an exit point at the surface. This re-emergence of underground water is known as a spring or resurgence, a characteristic feature of karst hydrology, and often a vital water source. Cave formation. Large underground spaces formed by water sinking and flowing through joints and bedding planes, often linked by swallow holes, may contain water or ponds. Stalactites versus stalagmites. Stalactites hang from cave roof, sharp, slender, downward growing, formed by dripping water. Stalagmites grow from cave floor upward, shorter, fatter, more rounded, formed by water dripping down. Natural pillars, formed when stalactite hanging from roof joins with stalagmite growing from floor. Limestone gorges, formation process, vertical cave sides collapse, formation process alternative, river cuts across and down into limestone. The economic significance of limestone regions. Construction and infrastructure. Key in construction for cement, concrete, asphalt, and aggregate for roads. Used as dimension stone. Industrial and chemical applications. Essential in industries as a flux for steel, in glass manufacturing, and for paper, plastics, and paints. Agriculture and environmental services. Neutralizes soil acidity as agricultural lime to boost crop yields. Used in water treatment and to reduce emissions via FGD. Tourism and regional development. Unique karst landscapes drive geotourism and revenue. Quarrying creates employment opportunities, supporting regional economies. Industrial applications. Cement production. Essential raw material for cement manufacturing industry. Metal smelting. Used in smelting processes for tin and iron production. Tourism destination. Beautiful landscapes attract visitors worldwide. Unique geological formations create natural attractions. Water resources. Underground water source. Natural storage and filtration system. Springs provide clean water supply. Grazing land. Provides pasture areas for livestock. Natural grasslands for animal feeding. Key benefits summary. Construction. Cement raw material. Industry. Metal smelting. Tourism. Natural attractions. Water. Underground supply. Agriculture. Grazing land.